Hi folks, in this video, I'm going to show you how to perform a one-way repeated measures ANOVA using JASP. First open up JASP. Once JASP opens, in the upper left corner, go to Show Main Menu, go to Open, go to Data Library, and go to ANOVA. You can go with alcohol attitude since it says that demonstrates the use of a repeated measures ANOVA. When you open it up, become familiar with the data set. You can see that it says that it provides attitudes towards water, wine, and beer after watching a positive, neutral, and negative imagery of that drink. Each participant featured in each cell is a 3x3 design. And so this is a 3x3 repeated measures ANOVA, but we could perform it on the basis of a one-way repeated measures ANOVA. The key here is that all participants are receiving all possible exposures in this particular data set. And so that's completely fine for purposes of this test. So to perform the repeated measures ANOVA, we're going to go to ANOVA and repeated measures ANOVA. This box is going to come up and you can see that there are different repeated measures factors. And so remember, when we use ANOVA, we have to have at least 3 sample means or more. And so what we're going to do in this case is we're going to take the values for beer positive, beer negative, and beer neutral. This is 3 levels though, so we have to add in a 3rd level and type in level 3. Once we have 3 levels, we can then take beer positive, beer negative, and beer neutral, and we can move them over to the repeated measures cells here, which represents level 1, level 2, and level 3. Remember, these people are being assessed for their alcohol attitudes in response to an image of a positive image of beer, a neutral image of beer, and a negative image of beer. This can be done for wine and water as well. Because we're interested in a one-way repeated measures ANOVA, this is the appropriate design in this case. As we usually do, we want to come down and make sure that we select our descriptive statistics, that we check for our basic assumption of sphericity, so that's Moshly's test of sphericity, and if the sphericity assumption is violated, we want to go ahead and select greenhouse geyser, okay? In addition, if we have a significant ANOVA, we need to be able to determine where the significant differences lie, and so we'll click on post hocs. We'll click the repeated measures factor and move it over to the box, and we'll use our Bonferroni correction procedure in order to do so with 95% confidence intervals. So once that's there, we can go ahead and take a look at our findings. And if we first look at the descriptive statistics, you can see that level 1, level 2, and level 3 each have the same 20 people, 20, 20, and 20. Those are the same people. And the mean value for that beer with positive, neutral, and negative imagery is 21, 4, and 10, with standard deviations as such. If you were to take then and say, well, what is the basic assumption of sphericity? Is that assumption violated or is that assumption met? We would jump right to the p-value and we see that it's larger than 0.05. So very similar to Levine's test in independent groups ANOVA, we want that p-value to be larger than 0.05 because it means that the variances and the standard deviations for each level of the independent variable is not statistically different from each other, and that's desirable. So because we met the basic assumption of sphericity, we can go ahead and look at the sphericity assumed line when we look at a repeated measures ANOVA here. So once again, we have a repeated measures factor, and we can look at the none line because we met the basic assumption of sphericity. If we violated the assumption of sphericity, we would be looking at the greenhouse geyser line. So looking at the sphericity correction of none, since we met the assumption, once again, we would determine the sum of squares between and within, and 2856.433 is the amount of the total variability that is explained by each of the 3 levels for the independent variable. The degrees of freedom would again be determined by taking k minus 1, where k is the number of levels for that independent variable. And so because we have 3 levels minus 1 restriction, we get a degree of freedom of 2. You took the sum of squares between, divided by its degrees of freedom, you would get 1428.217. And then similarly for the residuals, or the sum of squares within, or the error term, we would find that there's 3088.233 amount of sum of squares left out of the total sum of squares. We would take n minus k, which is the total sample size, minus the 3 levels of our independent variable. You would see that we would get 81.269 by taking 3088.233 divided by 38.000, and you would get your mean square of 81.269. Therefore, to determine the observed F statistic, we would take the mean square between divided by the mean square within. So the 1428.217 divided by the 81.269, and we would get an F statistic of 17.574. We would then compare this F observed value to the F critical value, which we've shown in previous videos, and we would see that the p-value is statistically significant because it's smaller than 0.05. So this tells us that there is a statistically significant difference in the attitudes of beer depending upon if we're provided with an image of a positive, neutral, or a negative image of beer. But to determine where those significant differences lie, we need to look at the post hocs. So let's scroll down and look at the post hocs, and you can see the p-values that are Bonferroni corrected, level 1 versus level 2, level 1 versus level 3, and level 2 versus level 3. You can see that there are statistically significant differences between level 1 and level 2 and level 1 and level 3 as evidenced by p-values for the post hocs that are smaller than 0.05. To determine where these are schematically, we would then have to go back and see, well, what level 1 represented. Here we saw that that was represented with positive image of beer, level 2 being a negative imagery of beer, and level 3 being a neutral image of beer. So when we compare these post hocs and we see that level 1 versus level 2 is significant, that tells us that a positive image of beer gives us a positive attitude about beer compared to a neutral image. And similarly, when given a positive image of beer compared to a negative image of beer, we see once again that there's a significant difference in that way. And so I hope this video was helpful. We'll see you all in the next one.